right, babies, we're doing 10, 13 data flow diagrams. I love these, by the way. I avoid them because I feel they... data flow diagrams are literally just a view on the organization from a data's perspective. But once you see something like that or do something like that, you're never the same. So anytime I want to do that, there's always a lot more resistance than I would like. And the reason for that is basically because if you're looking at how the data processes itself through the corporation, and when that becomes visual, then the whole corporation kind of starts looking different, because you start looking at people and seeing the data that comes out of them and it goes where. And like different, basically like segments, like accounting departments or shit like this, financial departments, and what they receive and what they have. Now that I mention it, it becomes a lot more systematic, because there becomes a flow of like this controls this and takes that and moves here and all that stuff. So I don't know, I felt it's something I wanted to say. What the hell? I'm back, don't worry about it. So data flow diagrams show where data comes from, which activities processes the data, and if the output results are stored or utilized by another activity or an external entity, right? So it kind of like splits the organization into, I need that data, I did this with it, I'm sending it there, that's how it looks like right now, right? The description, of course, is gonna be a whole lot of like shit, so let's go for it. Data flow diagrams portray the transformation of data. They are useful for depicting a transaction-based system and illustrating the boundaries of a physical, logical, or manual system. Aha, see? Everything I talked about earlier, but more fancily described. But interesting, because like, you could look at the organization by the people and how they act with each other and how they interact and how they work with each other, or you can look at the results of their interactions and actions. And I feel like the data flow is the result, is the object part of the organization. It's the objectification of the organization. While looking at the people and their interaction and how they interact with each other is more looking at the actual, what's it called? Subjectification of it. Yay. Data flow diagram illustrates the movement and transformation of data between external entities and processes. The output of you get it, right? Like it's literally like something does something, and this is what happens afterwards, or this is what happens inside, and this is where the data comes in and this comes out, right? What we're doing is we're literally talking about driving engines of a system. The entity becomes its own big kind of like, it is a big system, but we never normally look at it that way. So with the data flow, you'll be able to do that. It also illustrates the temporary or permanent repositories referred to as data stores or terminators, where data is stored within the system or an organization. The data defined should be described in a data dictionary. See data dictionary, page 247. We just saw that. Okay, systems overview rules. I'm going to read something to show you that this is basically systems thinking, right? That's basically it. A system is basically two things, literally two things, repeated left and right and all that kind of stuff. Systems thinking explained. Make it better. If I had the book, I'll just get the book, but I let somebody borrow it. In systems thinking, there are two things that are always happening. There's something flowing somewhere, right? And there's somewhere where it is actually kind of like, I forgot what they call it. There's a flow. What are the key principles of systems thinking? There's a flow and there's a silo. It's not a silo. What's it called? One second. Let's see if the AI repeats fast enough. Hot damn. No, I don't mean flows and delays, motherfucker. I mean a flow has to stop somewhere before being processed differently. Really, man? A stock. What the fuck, bro? What the fuck? So the normal system has basically two things. It's a stock and a flow. But there's in between the stock and a flow, there's basically a conversion system, a processing point, and then at the end of it, there's kind of like a feedback loop. It's a redirection, right? So there's a stock of something, which is basically what we're talking about is data, and it goes into somewhere in the enterprise. Why am I looking at you? Somewhere in the enterprise. And that somewhere in the enterprise, let's just say like sales numbers go into the accounting system. And what the accountants do is they take that data, they translate it into basically like balance sheets, I don't know, like stock prices, assessment, asset deterioration, all kinds of things, deprecation systems or charts. And then what leaves from the sales and all other stuff is kind of like the different data that like the CEO will read, and then other data that salespeople will read, or other data that operations managers will read, right? And all of these are basically like, those are the sales data that came in was converted by the accounting department. And I was kind of like, the outflow, because it had to flow into the department and then flow out of the department. And as it flowed out of the department, what it did was it basically went to different departments, and each one kind of like had a different feedback loop, or kind of like got the information differently. But the word I was looking for is not silo, is stock. Why? Because stocks. A stock is basically where something piles up, and then basically you use it and something else moves because you're using it and you're consuming it. And that is the transfer of energy, or the transfer of resources within the system. Anyway, look at that. I actually had the AI open for you. But now we're back to Yeah, we're back to the description. So data flow diagrams are basically like this. It's like external agent, output data, input data, external agents. Oh, nouns, okay. And the data process is basically a verb, right? Because like we mentioned it in I think a video or 2 videos ago, where we're talking about like, if we're looking at an actual, when we're concept modeling a restaurant, we have to kind of like separate the kitchen from the outside, but even the outside has a bar area for like food, for like drinks, and then a barista area, and then a station for basically the servers. And there's the in-between. So like, the kitchen kind of like does something, but the kitchen is always also connected to the servers within the kitchen's realm. And then the servers carry stuff from the kitchen to the outside, but the kitchen's also basically connected to the freezers, to the inventory, to the preparation stations, to the vegetable areas. I have no idea. So there are like different kind of like parts of every single moving object. And those are and the verbs are basically what connect these parts. So external agents, they're kind of like telling us the same thing, phrase naming. They're pointing at this fucking stupid example they gave us about the name. And so the next level of data flow diagrams is level 1 diagram. Level 1 diagrams illustrate the process related to a system with the respective input. Is this a level 0? Okay, this is a context diagram, not a data diagram. And so what they did is the data process that's here, that's like 1, phrase, verb, noun, phrase naming, they kind of like split them, right? They split them into kind of like, if this data comes from here, it goes through this. If this data comes from here, it just goes through this, right? I feel what they're trying to do is kind of like tell us that there are like multiple external agents and multiple processes for almost different data that come in a certain kind of way. I have no idea, right? Because this one here is connected to this, so it's just a bit, level 1 is a bit more detail, basically. Further levels of the data flow diagram, level 2, 3, or so forth, break down the major processes from level 1 diagram. So I assume this process kind of like goes into more details from level 1 to level 2, because you kind of need to know, level 2 is you're diving deeper, or you're kind of like exploring a lot more details and bringing them to the surface. Break down the major process from level 1 diagram. Level 1 diagrams are useful to show the internal partitioning of the work and the data that flows between the partitions, as well as the stored data. This is the data that flows, right? Input data noun, output data noun, output data noun. That's the shit that they're talking about here, right? Input data, output data, kind of like, yay, we're actually working on something. Logical data flow diagrams basically represent the future of essential state. That is, what transformations need to occur regardless of the current physical limitations. Physical data flow diagrams model all the data stores, printers, forms, devices, and other manifestations of data. It has to, right? Because ultimately, I feel like the physical data flow diagrams are kind of like modeling where every output of data happens and where every input happens, whether it comes from a computer or ends up on a server somewhere, right? And the physical diagram can show either the current state of how it will be implemented. It will be implemented, basically. And what are the elements? Externals, data store, process, data flow. You get it? Externals, flow, process, flow, right? So what are the externals? Entity source sink. An external entity source sink is a person, organization, automated system, or any device capable of producing data or receiving data. An external is an object which is outside of the system under analysis. Externals are the source of and or destinations, sinks of data. Each external must have at least one data flow going or coming from it, or else what's the point? Like, why would we mention it, right, if it's not connected to us? Externals are represented by using a noun inside a rectangle and are found within context level diagrams as well as lower level of abstractions. A data store is a collection of data where data may be read and repeatedly and where it can be stored in the future use. Again, like, I don't know, it's a database. It's a place where data is, where you can reach it and read it and kind of like edit it if you fucking want to, or delete it, whatever. A data store is represented as either two parallel lines or an open-ended rectangle with a label. This here, you see it? See the upper line and lower line? They're kind of like showing you that this is where the data stopped moving. A process can be a manual or automated activity performed for a business. For a business reason. A process transforms the data into an output. Naming standards for processes should contain a verb and a noun. Each process must have at least one data flow going to it and one data flow coming from it. Wait, I'm not... Yes, a verb and a noun, because one does this way, right? So data process is represented as a circle or rectangle with rounded corners. Oh, okay, so this is a circle, but a rectangle with rounded corners, basically. Rectangle, not square. In the data flow, the movement of the data between external and process of the data store is represented by data flows. Look at that. The movement of data between the external and a process, and a data store is represented by data flows. The data flows hold processes together. Every data flow will connect to or from a process transformation of the data. Data flows show the inputs and outputs of each process. Every process transforms an input into an output. Data flows are represented as a line with an arrow displayed between processes. Yay, line. You get it? See this arrow and a line? Wow. It leads somewhere as this flows here. Data flow is named using a noun. Output data, input data. I don't know. External agent, data process, output data store. Amazing. Usage considerations. What are the strengths? Maybe be used as a discovery technique for processes and data, as a technique for the verification of functional decompositions of data models. I think it's very important to understand what's going where and what's being received from it, or why. Are excellent ways to define the scope of a system and all the systems interfaces and user interfaces that attach to it. Yes, because it connects where everything is going and from where it's coming. Most users find these data flow diagrams relatively easy to understand. They help to identify duplicate data elements or misapplied data elements. Illustrate connections to other systems. Exactly. Help define connections to other systems. That's important, right? Because like so far what we're doing is we're looking at like one thing. But this one thing could be basically connected to many of the same size things within a big thing, right? Because like systems within systems. Your body has different organs that do different things, and each one operates in a different way. So think about it that way. Flows are your blood vessels. Help define the boundaries of a system. Can be used as part of a system documentation. Helps to explain the logic behind the data flow within a system, of course. And what are the limitations? Using data flow diagrams for large-scale systems can become complex and difficult for stakeholders to understand. Of course, most stakeholders will not understand. And most stakeholders do not fucking want all the data. They just want, right? It's bullshit, but like, you know, there are individual metrics for that correlate. Okay, we have a thing called pure functions in code, where it's a function. As long as you're giving it one thing, it will output the exact same result if you're giving it the same thing. If you give it the same thing over and over again, it outputs a different result. And it does that with anything you give it, right? It does not change. It always translates whatever you give it in a certain way. And that's the purest form of a function. It's simple, straight to the point, right? Like, y equal x plus 1. Whatever, anytime you give it 2 as x, it will output 3 as y, right? That's it. It doesn't change. But like, you know, that's the purest data form. That's the smallest point of data, basically. And then you have metrics that are kind of like, you know, our growth. Like, what do you measure our growth? There are like 15 metrics that measure growth, and each one of them measures like different kind of elements of different approaches. So like the complexity kind of like, there's a lot more high-level the more high level you go, the more complex the actual data becomes, but it's simplified because like a CEO only wants to see if we're growing or not, maybe. But a chief engineer wants to see how we're growing and what's the cost of our growth and where are the constraints or shit like this. So impressive. Well, we don't need to teach, not everyone needs to understand the fucking data flow. And, but it is actually very important for the people that need it. Different methods of notation with different symbols could create challenges pertaining to documentation. Does not illustrate a sequence of activities. Yes, like, you know, data flow does not necessarily mean if this happens, this happens. It just means this is how things pass. Like it does not allow us to predict. It's a documentation. And data transformation processes say little about the process of or stakeholder. Yeah? So like, you know, the way the data transforms says nothing about like efficiency, effectiveness, or any of that shit. We don't know. All we know is data moves from here to here. Cool beans? All right, perfection. Yalla guys. I'll talk to you in the next video.